My name is Suram and I welcome you all in the next lecture of Icse Physics Standard 7th, Chapter number 4, Light, and the book is Essential of Icse Physics, publisher Bharati, Bhawan. So Chapter 4, Light, we are going to discuss in this whole video. Light. So first of all we should know what is light. Light, as you all are knowing, it is a form of energy, as you have studied in the previous class also. Light, it is a form of energy that excites in us the sensation of vision, right? So light always travel in the straight line path, that you all are knowing, and its speed is 3 into 10 to the power 8 meter per second, right? And the speed is different in the different media, right? Like glass, light can travel in glass also, it can travel in water also, right? So this speed of light changes in the different mediums, right? So next up is a reflection of light. Reflection of light is what? It is the bouncing back of light. As you are knowing, as we throw the rubber ball onto the wall, it returns back, right? Same way, when the light falls on the object, it also comes back to our on direction, right? So bouncing back light when into the same medium after striking a smooth surface, that is known as the reflection of light. It is same way as we are throwing the ball right onto the wall, it comes to us, right? That is known as the reflection of light also. It is because of the reflection of light from the surface, from the various surfaces, we are able to see that surface only, right? So if the reflection of light is not there, it means we will not be able to see that object, right? For example, air is not able to reflect the light, so that's why we can't see the air, we can only feel it, right? We can feel the presence of air, but we can't see the air. We can see the dust particles in the air because the dust particles are reflecting the light, so we are able to see only that object which are reflecting the light, right? So reflection is of two types, right? Types of reflection. It is the regular reflection and there is the diffuse reflection. Diffuse reflection, or also known as the irregular reflection, right? So very first is the regular reflection. So it is the reflection from the smooth or polished surface, that is known as the regular reflection. For example, the reflection from the plane mirror, right? So such that when the light falls on these types of surfaces, a parallel beam of light is falling on the surface, it get reflected as a parallel ray beam only, right? Parallel beam of light get reflected back into the same medium, right? Then we have the diffused reflection. So it is a reflection from the rough surfaces or the uneven surfaces, right? All the surfaces around us, you can see it is the rough surfaces only, right? That, for example, a wall, right? Earth, right? Earth surface, right? Any kind of other surface that is not a plain surface, that is not a smooth surface, that all are the rough surfaces only, right? Uneven surfaces. It is because of the uneven surfaces, it is because of the rough surfaces we are able to see all that objects, right? Plane mirrors. What are the plane mirrors? A perfectly smooth surface from which the light reflects in one direction, that is called a plane mirror, right? You can see the light from the plane mirror, it is get reflected in the one direction only, right? There are some terms related to the reflection. We will study one by one all these terms. First is the ray. A narrow beam of light or narrow stream of light is called the ray of light, right? Then we have the mirror. Mirror we have discussed already. It is a perfectly smooth surface having a layer of aluminium or silver at the back, that is called silvering. Because of the silver surface, we are able to see inside the mirror. Otherwise, it will be a simple glass only. Then we have the incident ray, a ray of light that is traveling towards the mirror, that is called the incident ray. Then we have the reflector ray. Reflector ray, a ray of light traveling away from the mirror after striking away from the mirror, that is known as the reflector ray. Then next, students, we have points of incidence. It is the point where the incident ray first strike, right? It is a point where the incident ray first strike or first meet, that is known as the point of incidence. Then we have the normal. Normal, it is a perpendicular line drawn on the point of incidence. Where is the point of incidence? We draw one perpendicular line, right? that is known as the normal line. Then we have the angle of incidence. Angle of incidence is what? It is the angle between the normal ray and the incident ray, right? That is known as the angle of incidence, denoted with small I, right? Then we have the angle of reflection. It is the angle between the normal and the reflector ray, that is called the angle of reflection. It is noted with the small r. So here we have this diagram, right? This shows the n is the normal, r is the reflector ray, I is the capital I is the incident ray, right? Okay, and where these all three rays are meeting, that is called the point of incidence, right? So angle between incident ray and the normal, I and n, that is called the angle of incidence I, and angle between n and r, that is known the angle of reflection r, right? So our next topic now, that is very important again, laws of reflection, right? So very first is, now we have discussed all these terms, so we should know, we are going to use all these terms now in this case, right? So very first law is incident ray. You all are knowing now what is incident ray, reflector ray and the normal. We have used the three things here: incident ray, reflector ray and the normal. At the point of incidence, fourth thing is point of incidence, all lies in the same plane, right? Means they are lying in the same plane, they are lying in the same line, right? Means one plane, we can easily draw it onto the paper. As you can see this diagram only, these all are lying on the same plane, means there is not up and down. These three lines are not up and down, they are coming in the straight lane, right? Same plane, they are coming in same plane, mean they are not up and down, right? So these three lines like this is the normal line, right? This is the incident line and this is the reflector ray, right? So these all are lying in the same plane, means like this, they are all coming in the same plane. It is not like this, that one line is down, other line is up, right? It is not like this, it is coming in the same plane like this, right? That is the meaning of this first law of reflection, right? Incident ray, reflector ray and the normal at the point of incidence all lies in the same plane, right? So this is the very first law. I think it is clear to all that what is the first law of reflection. Then we have second, the angle of incidence is equal to the angle of reflection. As I have told you already, the angle of incidence is what and angle of reflection is what, or we can say simply angle I is equal to angle R, right? Angle of incidence is equal to angle of reflection. So this is all about the laws of reflection. Then next we have the image formed by a plane mirror, right? An image, first of all, what is an image? An image is the external representation of an object, right? So image is of two types, right? As it is the real image and the virtual image. There are the two types of images, real image and the virtual image. So first, what is the real image? An image that can be formed on the screen, that is called its real image, right? For example, the image formed by the camera, image formed by the projector, right? That is the real image, right? For example, then next we have the virtual image, an image that cannot be formed on the screen, that is called it a virtual image. For example, the image formed by a plane mirror, a concave lens, right? Because these images are not formed on the screen. If you are standing in front of the mirror, your image cannot be formed onto the wall after reflecting from the mirror, right? So that shows it is a virtual image, right? So you should remember what are the types of images: real image and virtual image. Then what are the characteristics of the image formed by a plane mirror? The plane mirror that we are usually watching in the morning when we are getting ready in front of the mirror, what are its characteristics? Some of you are knowing already, right? Virtual image. Virtual image, as you are knowing only now, what is the virtual image? Image that cannot be found on the screen, because when we are standing in front of the mirror, we are not able to get our image back on the wall, right? That means it cannot be found onto the screen, right? So first characteristics of the image is virtual. Image formed by the plane mirror is virtual. Second is erect. Erect means upright, right? Means as we are standing upside, our head is upside, same image is seen in the mirror also, right? Means it is not like that our head is down and the legs are up, right? It's not like that, is it? So it is erect. Erect means upright. As we are standing in front of the mirror, our image will also be same, right? Then we have of the same size as the of the object. What is our height? That our height is same as in the mirror image also, right? Characteristics, next characteristics of the image is it is of same size as that of object, right? Size of the image is same as that of object. At the same distance from the mirror as the object, right? If you are standing 2 meters away from the mirror, right, your image will also be inside the mirror at 2 meters, right? So object and its image distance from the mirror will be same, right? That is the fourth. And the last one is it is laterally inverted. Laterally inverted means what? If you are raising your left hand in the mirror, it seems to be right hand in the mirror. In the image it seems to be right hand. That is called the lateral inversion, right? Clear? The interchange of left and right, is it? Interchange of left and right, that is known as the laterally inverted, right? So these are the 5 characteristics of the image formed by a plane mirror that you must remember. There is a question based on this also that we discuss later. Then we have the lateral inversion. Lateral inversion is what? The interchange of left and right between the object and its image, that is known as the lateral inversion, right? So it is due to the reason that the letters are written inverted on the ambulance also, you might have seen, right? That it appears correctly to the drivers which is moving ahead, right? All the vehicles which are moving ahead, they can read the word ambulance correctly and they give the pass to the vehicles that is coming back, that is ambulance, right? So might have seen that is written already inverted, means it is laterally inverted. Lateral inversion I have told you already in the previous topic also. It is the interchange of left and right between the object and its image in the mirror, that is known as lateral inversion, right? Then we have the next topic, that is the colors. Colors are, light appears to be white, but it is actually a mixture of 7 colors. Bibgyor: violet, indigo, blue, green, yellow, orange and red. Shortly we can write Bibgyor. So it gets splits into the constituent colors when light passes, especially from the glass, sometime water at the certain angles, right? Rainbow is one of the common example. You might have seen that there are the 7 colors in the rainbow, is it? So what are the primary and secondary colors? You might be knowing what are the primary colors. Red, blue and green, these are the primary colors. So if we mix certain colors, then we get the secondary colors: cyan, magenta and yellow. These are the secondary colors, right? So color addition is used into the television and the computers to produce the colored images, right? Then next we have the color of an object. Color of an object actually depends on the color of light which it reflects, right? Which color it adds or which color it subtracts, right? For example, a rose appears red in white color. Rose appear red in white light because it reflects or it adds only red component of white light and absorbs or subtract the green and blue components, right? So that's why we are able to see the red color of the rose. Addition and subtraction of colors. White, from the white light if we subtract blue, right? In the white light if we subtract blue, means red, combination of red, green and blue. If we subtract blue in this case, then red and green combined will have yellow color, right? Means if from the white light if we are subtracting blue color, we are getting the end color, that is yellow, is it? Then we have violet, if we subtract green color from the white light, then red plus green plus blue. From these 3 colors if we are subtracting green color, then red plus blue, it becomes magenta, right? Final color will be magenta. Then we have white minus red. If we subtract the red color, right, then red plus green plus blue minus red, it will be green plus blue will be cyan color, right? So this is how the color addition is done and the subtraction is done. Then mixing of colors, it is a process of color subtraction that we produce in printing, right, in dyeing, in painting, etc. That is called the mixing of colors. So white light, white when it is mixed with red and blue, so red, green plus blue minus red plus blue, the final color will be green. So this is how the mixing of color is done. So that is all about this chapter, right? We will discuss about the question answers in the next lecture.